Let's have a look at this one. Now, this will become a lot easier if you understand the graph of a modulus. So for example, if I look at the modulus of x minus 2, y equals to modulus of x minus 2, the graph would bend at x equals to 2 and it will move like this, right? So keeping this particular piece of information in our mind, we can draw the graph for this and this and this, right? So let's try to generate a graph for these equations first, and then we will try to look at what the question is talking about. The number of integer solutions of n that satisfies this inequality is what the question is talking about. So if I have to draw the graph of these three individual modulus functions, then I understand that these modulus functions are going to bend at the value of n is equals to 60, n is equals to 100, and n is equals to 20. Clear? Now, instead of x, let me take an n over here, take the excess value of n on this axis, right? Now, if I have to look at n minus 20, it is going to bend at n equals to 20, right? So now if I have to draw a equation or a graph for modulus of n minus 20, this is how the modulus of n minus 20 would look like. Now, similarly, let's draw n minus 60, modulus of n minus 60. If you look at modulus of n minus 60, you are going to generate a graph that moves very similar to the previous graph. So this is how it is going to move. And what about this one? Modulus of n minus 100, it is going to bend at 100, let's say. So this is your 100 that you are talking about. And this is going to be your graph that you are looking at of modulus of n minus 100. Now observe something very carefully. They're saying value of modulus of n minus 100 should lie between n minus 60 and n minus 20. N minus 60 should be on a higher side, should be on a lower side, and n minus 20 should be the highest. Where is the n minus 20 graph? This is the n minus 20 graph, correct? Now, if this has to be an n minus 20 graph, and look at this particular point. So let me just extrapolate this a bit more. So suppose at any point x, let's say I look at a point over here. What is this value? This is the value of n minus modulus of n minus 100. What is this value? This value is modulus of n minus 60. And what is this value? This is the value of modulus of n minus 20. Now n minus 20 is the largest, but n minus 60 is lying in between. So that means this is not the region that I'm looking at, right? Now, if you observe very carefully, then you will realize between this region, from this point to this point, n minus 20. So take this particular point and evaluate. You will realize n minus 60, modulus of n minus 60 is the lowest, modulus of n minus 100 is in the middle, and modulus of n minus 20 is at the maximum, right? So this is the region between this particular point and between this particular point, my inequalities are getting satisfied. Right? We have to now get down to the values of these 2 points and look at all the integer values of x, n between these 2 points of n, right? Now, what is this intersection being formed? This intersection is being formed by modulus of n minus 20 and modulus of n minus 100. Clear? This value is definitely greater than 20 and less than 100. So when you drop the modulus of n minus 20, you are going to get the value n minus 20. But when you drop the modulus of n minus 100 for this particular intersection point, the value of n is less than 100. That means when you are dropping the modulus, you'll have to say minus of n plus of 100. If you do this, you are going to get 2n is equals to 120, n will be equals to 60. So this particular point, the value of n is equals to, the value of n is turning out to be equals to 60. What about this particular point? This particular point is the intersection of modulus of n minus 60 and modulus of n minus 100, correct? This value is greater than 60 definitely. So what am I looking at? When I drop the modulus, it will be n minus 60. But for modulus of n minus 100, when I drop the modulus, this is less than 100. N is the value which is less than 100. And hence I'm going to take minus of n plus of 100. If you solve this further, you are going to get 2n is equals to 160 and n should be equals to 80, correct? Now, this value n is turning out to be equals to 80. So between 60 to 80, all the values of n, you will realize my inequality, the given inequality will be satisfied, and at no other value of n will it be satisfied. They are saying n is, you have to find n as the number of integers. So between 60 to 80, you have to look at the number of integers. So 79 minus of a 60, which is 19 integers, should be your answer to this question. They've just counted the number of integers between 60 to 80.